Algebra 2, 5.5, apply the remainder and factor theorems. When you divide a polynomial f by a divisor d of x, you get a quotient polynomial q of x and a remainder polynomial r of x. And we rewrite this, so we're taking polynomial f of x, dividing it by the divisor d of x, and we get our quotient polynomial q of x plus the remainder divided by the divisor. So the degree of the remainder must be less than the degree of the divisor. There are two ways to divide polynomials. One is polynomial long division, and two is synthetic division. So for example 1, we're going to use polynomial long division. So we have divide f of x equals 3x to the fourth minus 5x to the third plus 4x minus 6 by x squared minus 3x plus 5. And we write that just like we would write long division of numbers, with the number here and then what we're dividing by out here. So it's going to be just like when we divide numbers using long division. It's just going to be a little bit trickier. So, first thing we're going to look at is the first thing here and the first thing here. What do we need to multiply x squared by to get 3x to the fourth? And the answer is 3x squared. 3x squared times x squared is 3x to the fourth. 3x squared times negative 3x is negative 9x to the third. 3x squared times 5 plus 15x squared. Now we're going to subtract that so we can distribute our negatives and change our sign here. So this is a negative, this is a positive, this is a negative. And to make it easier when we're subtracting here, I added in a term for x squared and put a 0 in front of it. So now, since I changed my signs, we're adding. So 3x to the fourth minus 3x to the fourth is 0. Negative 5x to the third plus 9x to the third is a positive 4x to the third. 0x squared minus 15x squared is minus 15x squared. And then we bring down the plus 4x. Now we look at the first term here, which is 4x to the third, and we think, what do we need to multiply x squared by to get 4x to the third? So we know that it's going to be 4x, because 4x times x squared is 4x to the third. 4x times negative 3x is negative 12x squared. 4x times 5 is 20x. Okay, so we're subtracting this so we can flip our signs. So this becomes a negative, this becomes a positive, this becomes a negative, and then we add. So 4x to the third minus 4x to the third cancels out. Negative 15x squared plus 12x squared gives us negative 3x squared. 4x minus 20x is negative 16x. And then I bring down my minus 6. And then I look and see, what do I have to multiply x squared by to get negative 3x squared? The answer is negative 3. So then I multiply this out, so I get negative 3x squared plus 9x minus 15. I multiplied negative 3 times each of these parts here. And so now we're subtracting or flipping our signs and adding. So I'm going to flip my signs. Okay, so negative 3x squared plus 3x squared cancels. Negative 16x minus 9x is going to be negative 25x. Negative 6 plus 15 is a positive 9. So this is our remainder. So now we have to take our remainder and divide it by what we were dividing by. So at the end here, instead of writing r and negative 25x plus 9, we're going to write plus negative 25x plus 9 over our divisor. So x squared minus 3x plus 5. And this right here is our answer. So for example 2, we're going to do the same thing, but now we have a smaller divisor. So we just have x minus 2. So I'm going to look at the first thing here, which is x, and the first thing here, which is x to the third. So what do I need to multiply x by to get x to the third? The answer is x squared. So then I multiply x squared times everything over here. So x squared times x is x to the third. X squared times negative 2 is negative 2x squared. Now I subtract or change my signs and add, and I find that easier, so that's what I'm going to do. My x to the third and negative x to the third cancel. 5x squared plus 2x squared is 7x squared, and then I bring down my minus 7x. Then I look, what do I need to multiply x by to get 7x squared? And the answer is 7x. So 7x times x is 7x squared. 7x times negative 2 is negative 14x. I subtract or change my signs and add. So these cancel, and I get negative 7x plus 14x, which is 7x. And then I bring down my 2. So what do I need to multiply x by to get 7x? And the answer is 7. So 7 times x is 7x. 7 times negative 2 is negative 14. I change my signs and add. These cancel. And I'm left with 16. So then I add 16 over x minus 2. So that is our answer here. Okay. So now synthetic division can be used to divide any polynomial by the divisor of the form x minus k. If there's anything in front of the x, or there's a squared on one of the x's or anything, we cannot divide using synthetic division. So it's only if it's x minus something or x plus something. Okay, so what we do is, for example 3, divide this by this using synthetic division. So we draw our box just like we did with synthetic substitution. In the first row here, we have our coefficients. If we skipped any terms, we have to put in a 0, but in this case we didn't, so we don't have to put a 0 in. Then outside here, we put the opposite of whatever's with the x here. So this is x plus 3, so we put a minus 3 out here. So first step, we bring down the 2 Then we do negative 3 times 2, and that gives us the negative 6 that's right here. Then we add. 1 plus negative 6 is negative 5. Now I multiply negative 3 times negative 5 to get 15. Then I add, and I get 7. 3 times 7 is negative 21. 5 plus negative 21 is negative 16. So, that's our answer because we're out of numbers. So, this is our remainder. And we work backwards from here. So, this is our ones term, so our constant term. Then, this is our term with an x, so minus 5x. And this is our term with an x squared. Okay, we can also know we just start with a degree less than is up here. So this was x to the third, so this will be 2x squared minus 5x plus 7. And then we have to include our remainder. So plus negative 16 over, now we can't just say negative 3. We have to go back up here and write x plus 3. And that is our answer for that one. So it takes less room, but it, at least to me, seems like it can be easier to mess up. So now we'll try number 4. Divide x to the third minus x squared plus 4x minus 10 divided by x plus 2. So again, we have just x plus or minus something, so we can use synthetic division. So we're going to draw our box. The first row up here is going to be our coefficients. This is the third power, this is the second power, this is the first power, and this is our constant term. If we skipped anything, we would have had to put a 0 in. Then we take the opposite of whatever's with the x here. So negative 2, and that goes out here. We bring down our 1, and then we multiply. Negative 2 times 1 is negative 2, and then we add here. Negative 1 plus negative 2 is negative 3, and then we multiply again. Negative 2 times negative 3 is 6. 4 plus 6 is 10. Negative 2 times 10 is negative 20. Negative 10 plus negative 20 is negative 30. So, again, we go down 1 degree from this. So it's going to be 1x squared minus 3x plus 10 plus, and then this is our remainder, so negative 30 over our divisor, which is x plus 2. And that's how dividing by long division and synthetic division work. So using both of those methods, we can find the remainder, but it takes a while. So they came up with the remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So, an example. In example 3 up here, we had f of x equals 2x to the third plus x squared minus 8x plus 5. And we're dividing by x plus 3, which if we want to write it in this form, we have to write it as x minus a negative 3. Because these are the same and we want to write it in this form. So, to find the remainder, we can use the shortcut of just plugging in negative 3. So f of negative 3 equals 2 times negative 3 to the third plus negative 3 squared minus 8 times negative 3 plus 5. So I get 2 times negative 27 plus 9 plus 24 plus 5. So 2 times negative 27 is negative 54 plus 9 plus 24 plus 5. Then this simplifies. So negative 45 plus 29 equals negative 16. Okay, so this is what the theorem is saying our remainder is. And if we look back up here, our remainder was negative 16. So this works for any equation and a divisor in the same form that we can use synthetic division for. In the factor theorem, a polynomial f of x has a factor x minus k if and only if f of k equals 0. So it's kind of like how 2 is a factor of 8, because when you divide 8 by 2, you get a remainder of 0. It fits in there evenly. So it's the same concept, but with polynomials. So, as an example, we are going to do x squared plus 3x plus 2 divided by x plus 2. Right? If we divide this, because this factors into x plus 2 times x plus 1, these cancel and we get x plus 1 with a remainder of 0. And we can use either long division or synthetic division and make sure that our remainder is 0. Okay, so if we double check this with the remainder theorem, our k here is negative 2, because x plus 2 is the same as x minus a negative 2. So I can plug negative 2 in. So negative 2 squared plus 3 times negative 2 plus 2 is 4 minus 6 plus 2, which is 0. So our remainder theorem also tells us that our remainder is 0. So now we're going to have a couple of examples here. Example 5. Factor each polynomial completely given that x minus 4 is a factor. So if it is a factor, we can divide by that, and then we can factor from there. So we know that x minus 4 is a factor, so I'm going to use polynomial long division to do this one and synthetic division to do this one. But you can pick either method for either question. It's whichever you prefer, because this is in the form that we can use synthetic division. So we switch our sign here, so we get 4 on the outside, and we write our coefficients down. 1, negative 6, 5, and 12. We bring down our 1. 4 times 1 is 4. We add, get negative 2. 4 times negative 2 is negative 8. Add, we get negative 3. 4 times negative 3 is negative 12. So we get a remainder of 0, which is what we want. Now we know our degree goes down by 1, so this is x squared minus 2x minus 3. And this, we need factors of negative 3 that add to negative 2. So that's negative 3 and positive 1. So this factors into x minus 3 and x plus 1. And then we still have this as a factor, so I'm going to write that out here in front. And this is this factored completely. So now for this one I'm going to use long division. So x to the third minus x squared minus 22x plus 40, x minus 4. So what do I need to multiply x by to get x to the third? The answer is x squared. So x squared times x is x to the third. X squared times negative 4 is negative 4x squared. I flip my signs and add. These cancel. This gives me 3x squared minus 22x. What do I need to multiply x by to get 3x squared? The answer is 3x. So I multiply that out. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. I flip my signs and add, and I get negative 10x. Bring down my plus 40. What do I have to multiply x by to get negative 10x? Negative 10. Negative 10 times x is negative 10x. Negative 10 times 4 is positive 40. Then I flip my signs and add, and everything cancels, so my remainder is 0. Now I have to factor this. So I'm looking for factors of negative 10 that add to a positive 3. And my answers are 5 and negative 2. So if I'm writing this in factored form, I know x minus 4 is a factor, so I'm not going to forget that one. And then I have x plus 5 and x minus 2. So that is the completely factored form of that one. And then for example 6, it's a multiple choice question. So one of these is going to be correct. So 1, 0 of f of x is x to the third minus 2x squared minus 23x plus 60 is x equals 3. What is another 0 of f? So we can do this a few ways. We can divide our polynomial here by x equals 3 or x minus 3 and then factor from there, or we can use the remainder theorem. And the remainder theorem goes a little bit faster, so I'm going to use that one. So for the remainder theorem, I'm going to plug in my 3. So f of 3, just to make sure that this works, 3 to the third minus 2 times 3 squared minus 23 times 3 plus 60. Get 27 minus 2 times 9 minus 3 times 23 is 69 plus 60 equals 27 minus 18 minus 69 plus 60. 27 minus 18 is 9. Negative 69 plus 60 is negative 9. So that equals 0. So we do know that x equals 3 is a factor. So what is another 0 of f? So we plug each of these in, and if we get 0, then the remainder is 0, so that means it is a factor. So I'm going to plug in negative 5. So I do negative 5 to the third power minus 2 times negative 5 squared minus 23 times negative 5 plus 60. And I get 0. So I don't have to plug in anymore. A is my answer. If I hadn't gotten that immediately, I would have had to keep going until I got one that gave me the answer of 0.